Alright guys, these are some problems that I've created to help you with your week 7 review problems on the College Board. So I made some problems that are similar to those, and then you can use these as examples to help you do the ones that are actually assigned on the College Board. So this number 1 will be like your number 1, so let's take a look at it. The graph of the function f is given below. G of x is negative 2x plus 2. And h is a composite function, f of g of x. Our job is to find h prime of 0. So first of all, what we want to do is we want to take the derivative of h, and to do that we're going to do the chain rule because that's a composite function. So the derivative of h will be the derivative of the outside function, which is f prime. And we don't do anything different with the inside, we just leave it as is. And we multiply that by the derivative of the inside now, which is times g prime. And our goal here is to now plug in the 0 for x. So if I do that, we will get h prime of 0 is equal to f prime of g of 0 times g prime of 0. All right, so first of all, let's do this, g of 0. Now that's the y value of the g function up here. So let's do that on here. This is the g function. It's not the graph, actually. It's the g function. So I'm going to take my g function here. I'm going to find out what is g of 0. So we're going to plug in 0 and see what we get. Now 2 times 0 is 0, plus 2 is 2. So this piece right in here becomes 2. Next, we need to find g prime of 0. So if this is g of x, then g prime of x is going to be the derivative of that. And the derivative of negative 2x is negative 2. And the derivative of 2 is 0. So we're just left with negative 2. So g prime of 0, well, g prime of x is always negative 2, so it doesn't matter what number's in here. G prime is always going to be negative 2. So we'll put that there. The last thing I need to do is I need to figure out what's f prime of 2. That means what is the slope of the f function when x equals 2? And this graph right here is the graph of f. So what's the slope of the f function at x equals 2? Well, x equals 2 would be right about here. And so we're on this line. And so I want to find the slope of this line. You could do this the long way or the short way. It doesn't really matter, but I'm going to go ahead and go this way. So it looks like the coordinates of this point would be negative 3, 3. And the coordinates of this last endpoint over here would be 3, 1. And to find the slope, we just do y2 minus y1 over x2, which is 3, minus x1. And that gives me negative 2 over 6, which is negative 1/3. And so, now that's one way you could do it. Another way you could do it is just start here at this point and just get to this point and look at your rise and run. So I would have to go down 2 and over 6. So down 2 and over 6 is negative 2 over 6, which is negative 1/3. So you could do it just by counting spaces, or you can use the little formula that I just used. But that's how you find f prime of 2. Now multiplying these together, you get a positive 2/3 is the final answer there. All right, let's move on to our next one. So for number 2, they're going to give you this expression. They want us to find the derivative of the function when x equals 2. So we're just going to take the derivative of this. Now before I begin, though, you'll notice that we have that 1 over x to the 4th, which hopefully you guys know we like to rewrite that by bringing the x to the 4th to the top and changing that to the negative. Now I'm going to go ahead and apply my derivative to each piece to get 6x minus 4x to the negative 5. And then now I'm going to rewrite this piece again, now that I've got my derivative all done, and I have this. All right, so that's my derivative, but they want me to plug 2 in for x. So if I do that, then I will have the following. And so that's 12 minus 4 over 32. And we want to get a common denominator there. I think that's the right answer there. And then we end up with 95 over 8. Final answer. All right, so just basically take the derivative first and then plug in the number. There's a few other problems like that. So number 3 is, in my opinion, probably the more confusing of all the problems on here. Here we go. Suppose that f of x is a function such that f of 2x is equal to 2 times f of x. And if f prime of x exists, then we want to find what's f prime of 2x. So basically what you're going to do with this problem is you're going to start with the weird-looking expression that they give you in the beginning. And then you're going to go ahead and just take the derivative. Now for this one, that's a chain rule. You're going to have the derivative of the outside multiplied by the derivative of the inside. And then for the next one, this is a constant multiple, so it just stays there. And then we take the derivative of f, which is f prime. So basically, just take the derivative on both sides. Now they want me to find f prime of 2x. Well, that's what this is right here. So I just need to get that by itself. So I would just divide both sides by 2. And it turns out that f prime of 2x is equal to f prime of x. And so what does f prime of 2x equal? Well, it equals f prime of x, which is a weird thing, but there it is. So basically just start with the expression that they give you, take the derivative on both sides, and solve for the part that they're asking about. But just as a special note here, just to make it more confusing, I guess, for some reason, they put a little 0 next to the x. And honestly, it doesn't matter. The 0 is something you can just ignore. It doesn't really mean anything. It just means a specific x value, so to speak. But it doesn't matter. So there's that. Let's go ahead and move on to the next one. So for number 4, I'm not going to give an example. It's pretty simple. The first thing you need to do, though, on number 4 is just go ahead and rewrite the problem that looks like this. You guys know that if you ever have an x to the 5th from the bottom, you're just going to move it up to the top as a numerator like that, right? So that's pretty much all you need to know to do that one if you're getting stuck on anything. The rest of it, I'm sure you guys do okay with. Let's go ahead and take a look at this problem here. This will help you with numbers 5 and 6. So the graphs of f and g are provided below. I'm going to go ahead and label those now. I'll call this one here the f function, and I'll call this one down here the g function. So if h of x is equal to 2 times f of x minus g of x, they want us to find h prime of x. So here we go. H prime of x is going to be equal to 2, stays there because it's a constant multiple. Derivative of f is f prime minus g prime. Now, usually they would give you a number to plug in and you would find the answers, but we can actually get numbers out of this without plugging anything in, and the reason why is because, as we talked about earlier on one of our other problems on this little help video, this means the slope of f at some value of x. Well, for f, since it's a straight line, the slope is the same all the time. So it doesn't matter what point you pick. So basically what they want there is they just want the slope of f. So in this case, the slope of this line, just pick 2 points, and you can either use the slope formula or you could do the rise and run method that I like to do. But either way, you should end up with a slope of 1. Now for the g function, we also want the slope of the g line. So once again, just pick 2 points, do the rise and run method. For this one, you go down 1 and over 2. Or you can use the y2 minus y1 over x2 minus x1 formula. But either way, you should end up with negative 1/2. So let's review. What did I do first? The first thing I did was I took the derivative of this, and I got that. Next, I recognized that the derivatives of these are just the slopes of those lines over there, and so I found those slopes. Lastly, all I need to do is simplify. So I've got 2 plus a half. Getting a common denominator and combining those together, I end up with 5 halves. So that's what you'll be doing on 5 and 6 is you're going to take the derivative of the expression that they give you, and then you're going to find the slopes of the line and replace those derivatives with those slopes because that's what the slope is for those functions. All right, and for 7 and 8, once again, I'm not going to do any example for that because basically all you're going to do is find the derivative of your function, and after that, plug the x value in that they give you. It's pretty straightforward. Nothing too tricky there. So that's it. Hopefully that was helpful, and we will see you guys in class. Have a good one.